All right, so we kind of started last Monday, which feels like a long time ago. We kind of talked about how, like, when we have these continuous distributions, we just kind of look at the area to figure out probability. Is everybody with me? Okay, so we're going to continue to look at area, but now we're going to do so with normal distributions. And when we do so with normal distributions, it looks a little bit different. Now, can I just, because it's not the same all the way across, I can't just do like that range over the range like we did with the uniform distribution. Okay? So instead, what we're going to start doing is dealing with the standard normal distribution, and your calculator can calculate all this kind of stuff for you. Now, when Miss Meister learned statistics, and when most of your teachers had to take statistics in college, we did not have calculators that did what your calculators do. So what we had to do was use a table like this one to find what your calculator used to do.
I'm sorry.
It's great. If you guys were to wonder, if you guys were to ask your teachers how much they hated statistics, they would say a lot. That's one of the components of why adults dislike statistics. Everybody good? All right. So instead of using one of those tables, we are going to use your calculators to do this, okay? So in the standard normal distribution, it's essentially distribution of all those. Do you guys remember doing z-scores? And the way we calculated that z-score is we did z was equal to x minus the mean over the standard deviation. And that ended up being the number of standard deviations from the mean. And it turns out that what your calculator can do is you can tell it kind of some boundaries, and it can tell you what the area in between two z-scores is. Everybody good? All right, so before we do this one, if we were to sketch this, so one of the things I always do with normal distributions is I like to draw them and label the mean and the standard deviation. Okay? And if I want to find what is the probability I get a z-score between -1, you guys, these are that's supposed to be -1 and +1. So between -1 and +1, are you guys with me that would, because this is a continuous, essentially what we're asking you to do is find the area between -1 and +1. Now, you guys, for the normal distributions, we kind of talked about these where we had that rule, that empirical rule. Do you guys remember the empirical rule? How many was within one standard deviation of the mean? 68%. We expect this to be about 68%. Let me show you how to find it on the calculator. Okay. So we are again dealing with a known predictable distribution. Okay? Which means we're going to go to that distributions menu in our calculators. So go ahead and hit second vars to pull up this distributions menu. Now, your calculators, hopefully, you two would be the ones where, hopefully ask you for a lower and an upper. Is that, when you hit, oh, no. Okay, sorry. I'm one step ahead. Sorry. Okay, now, what we want to find is how much area is accumulated in between these two numbers. So we're going to choose the C of the CDF is cumulative. Okay, that's the one we want. Okay? And you guys scratch out number 1. Obviously you can't, but you'll never use it for this class. Okay? So go ahead and choose option number 2. Now hopefully your calculator is asking you for a lower and an upper. Everybody good? That lower and upper is asking you to describe the shaded region. What's the lower boundary of the shading? -1. And then the upper is the upper boundary of where you're shaded. Where's that? 1. The next symbol, which is hard to understand, is supposed to be that curly QM. The mu for the mean. Okay? Which we're going to put, what's our mean right now? 0. And then the standard deviation is 1. And that should be what your calculator automatically fills. And what are we expecting to get? 68%. Go ahead and hit enter. Guys, I got 0.683. Everybody good? Yeah.
All right, just checking.
And what are we hoping to get for that one? Approximately?
79%.
Went 68, 95. You're thinking of Chevy Chevs when it's not normal. So we should get approximately 95%. And I think it works out to be 0.954. Is it close?
0.954.
All right. Are you guys with me that what's happening here is like predictable, yeah? And if I had asked you guys these questions without your calculator, so far you'd be able to do it because of that 68-95 rule. Like with a little bit of a review of that, you'd be fine. Obviously, we're not keeping it. We're going to start getting into more complex examples, okay? So, what if I ask you z is less than -1.45? That doesn't fit that rule, like, at all, does it? First of all, where is -1.45? Kind of there-ish, right? Maybe a little bit further left, but it doesn't have to be perfect. And where would I shade this one? To the left-hand side. Is everybody with me? So we're always going to shade the area we're finding. That's a really good way to communicate to Ms. Meister your thinking. Okay? But you guys, if I'm shading this one, what's my lower boundary going to be? -infinity. Go ahead and put that in your calculator.
Is there an infinity sign?
No, this is a silly thing.
It was not fun last year.
No.
I did 0 last
Here's what happens. You can't plug it in. However, you
So
guys.
said -1 e to the 999. Oh, yeah.
Yeah, that's why it starts with that. Yeah. Okay, you guys, you don't need to worry about that much. Okay? What happens is it's going to cut off whatever your lower boundary is. Okay? Because it finds the area between. If I make that lower boundary ridiculously small, is there any area left to cut off? Do you guys see what I'm saying? So to do the infinities, all we got to do is pick some really, really, really tiny number, tiny enough that that area that I'm cutting off is pretty much nothing. Okay? Now, so when I go to do that one, I might, for my lower, make it negative gajillion.
Alright. Negative bajillion is. And then upper would be the same.
So the upper would be negative 1.45.
Oh, yeah.
And my mean would be 0, and my standard deviation would be 1.
Is that always how it is? Mean standard deviation?
No, it is so far.
Alright.
It'll be very obvious. It will be obvious when it's not.
Mm-hmm.
Okay? We'll get, but you're not ready for it yet. Hey guys, did we get 0.073? Okay. Oh, you guys, we got 0.074. You got to make sure I round appropriately. What about the probability that C is greater than negative 0.2? Great. Now, there is no difference in these between greater than or equal to. Remember yesterday we kind of talked about, is it possible to get something exactly when you have a continuous distribution? Right, like a blade of grass that's exactly 2 inches. When it's continuous, exactly doesn't really happen anymore. You guys, the other thing I want to talk about before I put this in my calculator, I know you guys already put it in yours, okay, is this particular section is going to have lots of decimal answers, okay? Because z-scores could be decimals like 0.2. Like, it'd be really easy to confuse a z-score for a probability and vice versa. Do you guys get what I'm saying so far? Okay? So one of the things I want you guys to do is start thinking through, before you put it in your calculator, what should the answer be close to? Okay, like start trying to make some sense out of it. So when I look at this one, I say, well, I know greater than 0 would be 50%, right? So I'm hoping for an answer that's a little bit bigger than 50%. Right? What should my lower boundary be in this case? Negative 0.2. What should my upper boundary be? A gajillion.
Sorry, not good.
But,
4 billion.
a gajillion billions, yes. Yes. Okay, mean 0, standard deviation 1. What are we getting? 0.57? 9, great. And you guys, is that a little bit bigger than 50%? Yeah, like that feels like a good answer to me. All right, you guys try this last one. It's always one for now.
Did you hear my prank idea?
No. I took this with me.
Oh.
In case you were going to try to play.
No, I said that we should lock them. But then I thought you'd get mad.
It'd be funny, my keys are in here. But you know how I would handle it, right? Mr. Richards' keys opened, so I would have him come yell at you guys.
That would go away.
See,
Actually.
like, Richard yelling at you is way worse. Way, way worse than me yelling at you, and I know it.
No, actually you yelling is worse, because you don't really yell all that much, so it's scarier than you do.
Well, it certainly means more when I do, yeah.
Yeah, yeah.
It's like when you get a hug from me, because I'm not a hugger. Like, I have certain friends that if I give them a hug, they're, like, super excited. right? Because if I hug someone every day, then when they really need a hug, it means nothing.
It's not true. I used to think that's
Hey guys, what'd you get for this one?
0.869.
0.869?
Yeah.
And we're all in agreement on that? Sweet. See, this is easy.
Alright.
It's really just do you know how to use the calculator?
What is the z-score of the
Don't do it.
35th
Stop.
percentile? Let's draw this picture.
Oh no. Oh, cute.
Are you out of LaCroix?
I'm not out. I just
I
have one more in there. Let's start thinking about after lunch.
Put them all in there.
I know. I don't like to take up all the space because other teachers use this to put like their lunches and stuff like that.
Well, what if they want a refreshing cold LaCroix too?
They can buy their own.
Oh, so
That's not true. If anybody needs one, I just give them away. And people have, at least the math department has learned that when I do something nice and you want to say thank you to me, they bring me like a 12-pack of LaCroix. It's the best. Okay. Did anybody draw this picture yet?
Is it asking for a picture of the graph? Or like a picture
Okay,
of the normal distribution?
So it's going to be normal. Okay. You guys, where would the 35th percentile be? To the right of 0 or to the left of 0? To the left? Yes? Which percentile is 0?
50.
0 is the 50th percentile, yes? So it's, and percentiles describe that percent or lower. So essentially what we want to do is shade the lower 35% of the graph. You guys with, is everybody with me? All right, so just tell me when to stop.
Stop there. Stop.
No, it's more than that. It's like
Oh,
here.
oh my.
It's a third.
Yeah, alright, I guess. Alright.
And there's some value here, and what we know is this area is 0.35. So in this case, we know the area. We're trying to find the boundary. So can I use the same thing I've been using? No, because I need to put in boundaries for the thing I've been using, and I need to somehow tell the calculator the area, which, by the way, is working backwards, yes? So I better clear that up. So if I go into that distributions menu, do you see anything that might help us work backwards? In the inverse of the normal distribution. Everybody good? So choose option number 3. And holy moly, what does it ask us for? It asks us for an area. Do we know the area? Great, 0.35.
What? The norm.
Inverse norm.
Could you also use just 35 to make it 35%, or will it only take a decimal?
It only takes a decimal. Because it knows the area underneath it is smaller than 1. Okay, so that would be, and then 0 and then 1, yeah? Everybody good? Is anybody shocked to see that the number here is a little bit negative? It's not super far from 0. Does this feel good? All right, now, the upper half of the curve, upper 5%. Let's see.
Yeah, they just keep on getting worse. I draw that.
You guys, I'm not uber picky about them. Haley, help me out. Charlotte, help me out. Have I ever been picky about how you draw your normal curves? By the way, did you guys notice I wore my normal distribution t-shirt for you guys today? Hey guys, upper 5%. Now, You three, your calculators are slightly different than the others.
Alright.
Okay. Now, so help me out. Did your calculator see whether you shaded left or right? Like on this first question, you put in the 0.35, yes?
Yeah.
It asks for left, right, or center.
You guys have the option for left, right, and center. These guys don't. Okay. So, your calculator only thinks in left-hand areas. Okay? So, if it's 5% to the right, what percent's to the left? 0.95. So, you guys are going to do the inverse norm of 0.95 instead of 0.05. Because in here we knew the left-hand area. Your calculator only does left hand. Yep. Now, their calculators do left, right, and center. You would always be welcome to borrow one of mine that also does that. Okay. What's these scores? There would be two now that would correlate with the middle 85%. Are you guys with me that if it is the middle 85%, that there are actually two answers? Okay. And what can we say about these two answers if it's the middle? That this distance and this distance would be the same. Okay? And since I have a 0 in the middle, that would equate to a positive and a negative of the same number. Like this would, if it's, let's say that number is 2, if this is -2, this would be +2. Great. Okay, and so for you guys, you just put 0 in, yeah? Or put 0.85 and highlight the center. You guys.
We'd have to do
Did you do 0.85?
Yeah.
0.15.
So, combined, this is 0.15 and this is 0.15. Yeah? No. These two combined equal 0.15. The area is 0.075 for each of these. This area is 0.075, this one's 0.075, so that they add to 15%.
But what do we put in?
The point, so you're going to put in the 0.075.
This is
I got it. I think I just hit reverse norm twice or something.
But you're taking the natural log of it?
Why does it keep putting natural log?
So if you had accidentally hit natural log and then go from there, it fills this like formula into the natural log function. So like you want to have, I always like to be able to clear the screen before I do it.
I feel like I accidentally hit it a few times. So I keep seeing it. And then you had natural log that one time too.
Oh, I haven't done it yet. No, this is like the very first one. Oh, and did we ever do this one?
I did. But
Did we ever get the answers?
I don't know if you did, but.
Well, that one I actually happen to know what it is. There's reasons why I know that. That will be apparent in Unit 7. Whereas this one, I don't know what it is.
Yeah, because at this point.
You guys, what did we get for this one?
Positive 1.40.
1.40. We're going to go 3 decimals.
1.440.
Well, sorry, 1.440.
So. Wait, how do you want us to write it? Do you want us to write it in the brackets?
If it's you're not really finding the interval, like you kind of are, but I'm not going to be picky here. When we get to the stuff where I'm going to be picky, I'll tell you. We feeling okay? So we use the mean as 0 and the standard deviation is 1 when the probability we're finding is about a z-score. Okay? When the probability we're finding is about something else, we don't use the mean as 0 and we don't use the standard deviation as 1. So let's look at
Cow. All right. Oh, but you gave us.
But I give you, like I'm not going to not give you the mean and the standard deviation. All right, so the weights of cows are normally distributed with a mean. Oh, you guys, why didn't I say the weights of dinosaurs?
You didn't know that you were. That's all right.
That would have been so funny if I didn't know it. You're right, I didn't think about wearing the t-shirt that day. All right. Huh?
I'm just really reading it.
Normal distribution.
Normal distributosaurus. Nope, normal distributosaurus. Yeah. Okay, you guys, which weights would be unusual?
Anything
Above 690 and below.
Oh yeah.
2 standard deviations, yeah? So we would do 600 plus or minus 2 times 45, which is below 510 and above 690. Woohoo! All right. What is the probability that a cow weighs less than 675 pounds? So I'm going to draw normally distributed because I was told that it was normal with a mean of 600 and a standard deviation of 45. Now, give or take, where is 675 on this graph?
1.5.
It's about 1.5 standard deviations-ish. Okay? I don't expect them to be perfect. I expect them to be relatively close.
Do you want us to do the math to get it accurate?
No. Because, like if that will help you, sure. But, like, the scale actually counting out to exactly 1.37 standard deviations or whatever it ends up being. Like, what's the difference? It doesn't matter. Okay. Hey, guys. So I would expect our answer to be around 90 to 100%. 90-ish. Am I close? 0.953?
2. Oh.
So the probability that x is less than 675. Notice I'm not doing a z anymore. I'm doing an x because this isn't a z-score. It's an actual observation. Okay. Is 0.954. Is that what you said? Or 0.953 is how it rounds?
No, it rounds to 2 because it's 2, 2.
Like that.
Wait, what?
Now, you guys, this time that curly Q mu has got to be a 600. Nope, this would not be inverse norm because this time I have the boundaries. I'm trying to find the area.
So your lower would be.
Your lower would be negative gajillion.
And your upper would be 674.
675.
Same ways last.
But remember, for continuous, it doesn't really matter because think of it this way. 674.3 is also less than 675.
So where are we going on our?
In this case, this would be a normal question.
Oh.
So it depends on what you have labeled. If you have the labels down here, right? If what you know is the down labels down here, that means you have your boundaries. You want to pick the one that asks for your boundaries.
Okay.
And if what you have is an area, you pick the other one. And you guys, every year I have students who asked me how can I remember which one to pick, and the answer is, if it asks you for something you do not have, you picked the wrong one. Hit quit and just pick the other one. Do you guys get what I'm saying here? Okay.
So for like the percentile, would that
Well,
be?
we're not there yet. We got to draw our picture. Does anybody have questions on about the .952? All right. So now let's look at how much would the 40th percentile weigh. I'll draw my picture. I can label my mean. I can label my standard deviation. It was 45? And if I had to draw a picture of the 40th percentile, I would start doing this. And I would stop right there. Does everybody good with me stopping about there? Okay. And what is this? What is that 40% then? It is the area. So, which normal distribution thing do I want to use? The one that asks me for area. Do you guys get what I'm saying? And I'm not trying to make this I'm not trying to make you guys feel silly. Like, every year I have this conversation with every statistics class. Because this is something that it is confusing. There's lots to remember that have nothing to do with, it's how you calculate, not what it means. Are we all on the same page? And what are we getting? Pounds, in this case, yeah? We feeling good? Cows are big. 600 pounds is a lot. Moo. It's a fun game. You guys say an animal and make somebody else has to say make the noise of that animal. Frog. Fox. What does the fox say?
What? Fox make a little clicky noise.
Hey guys. The heights of 10-year-olds are normally distributed with a mean of 52 inches and a standard deviation of 4.3. You guys, how would we describe weirdly heighted 10-year-olds? That came out really. I got to rethink the wording of that question.
All right.
52 plus or minus what?
2 times 3. For like questions on these on the test, would you want us like how on the last one instead of finding like the Z, I guess we found like the pounds, you would want us to like label that.
Yes, please.
Okay.
If it's a real world context, you should have a real world answer.
Yeah.
Okay. You guys, less than 53.4? Is that what it works out? No, 43.4.
43. Yeah.
Less than 43.4, and then that would be more than 60.3?
60. I had 60.
60.6. You guys, I got 60.6. You guys, I would be unusually tall for a 5th grader.
I think I'm as tall as a 50.
You think so?
Yeah. I feel like our 10-year-olds aren't this tall.
It's like 64 inches.
Have you seen 5th graders?
They're tall. Those seem really tall.
I've seen them. They're kind of short.
I haven't grown since that age.
All right.
Whatever, like, just those means.
That's like crazy. Growth hormones. I don't know.
But 43 inches tall is like here.
Yeah.
Like saying that you have a few tall ones and some short ones is not that crazy.
It's just a mean being only like 10 inches shorter than me. Like the average sounds weird.
Maybe you're just this one.
Yeah, I am really short.
There's nothing wrong with being short. Longer lifespans amongst many other perks.
All right.
You guys, did everybody else hear the jealousy in Zoe's voice just now when I said I was going to live for a long time?
I'm not that tall.
Hey guys, if I wanted to write this out kind of like as this probability statement, between just puts the X, you know, between.
I like this one more
Yeah, most
than
people
what we
do.
were doing.
The discrete
Yeah,
the discrete distributions are harder to do, I think. They require more cognitive work than the continuous.
Yeah, it's like recognizing and flipping them a lot, but this is like you can write it.
This-
How
this
tall
com-
is the Q3?
That's not nearly as bad as you think it is.
Yeah, that's true.
Hey, you guys, what did we get?
0.581.
Did everybody get 0.581?
Yeah.
I'm assuming if you all get 0.581, then you got it right.
Hopefully.
I suppose I could actually calculate it. Oh, you guys, that's a terrible normal curve. I'm sorry to disappoint you.
Don't worry, ours are looking just as
Oh, nope, still not good enough. I hold myself to high standards.
Alright,
Right.
well, that'll do, I guess.
It's nowhere near my best. You guys. First of all, I already know I'm doing an inverse norm question because my variable is a height. So it's something down here is what I don't know. Where is Q3? Give or take. What? Are you guys with me? The mean is the 50th percentile. And Q1 and Q3 are like the 25th and the 75th percentile. Like they divide our data up into quartiles, yeah? So there's 3/4 of the data that's smaller than Q3. Is everybody good? So I know that the area is 0.75. I'm trying to find this value for x. And what are you guys getting for x? 54.90 inches. And you guys, looking at your picture, does that feel decent? Does that feel like a reasonable answer? Sweet. All right, you guys try these bottom two.
Would you recommend to keep writing or drawing out that normal distribution?
My expectation on like your test next week, not next week, but blah, 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 blah. You know what I'm trying to say on the upcoming test is that you would draw the pictures. So it's, I would recommend habit-wise that you. Not if it's the top 10%. because I only put my answers down, but I would expect to see graphs if this were, say, a test. Do we want to talk about any of these?
Okay. I was just gonna ask for that one. Your, like in this case, your lower would be 0, right?
No, you would still use negative gajillion.
I use 0 and I got same thing. Because you can't go below a 0 GPA.
I understand.
Or does it not really? Since it's on that side, it doesn't matter.
You want to go a lot of standard deviations below the mean. I mean, essentially, that's essentially what you need to do is a lot of standard deviations below the mean. So what happened is when you did 0 and you got the same answer, 0 is still like almost 5 standard deviations, or a little bit more than 5 standard deviations below the mean, so it won't make a difference.
I just.
For habit reasons, I think you should do negative gajillion, okay? Just
Wait.
start building that as your habit.
But if I do it in here, I get a different number. My upper is 3.0. If I put negative gajillion, I just got 2 different answers. I got negative 0.369.
You didn't do negative.
Oh.
So, I got the right answer and stuff like that, but I'm wondering how this works, is like if you were to try to do the top 0.0000001 percentile, like
Yeah.
the top one, and then 5.65, which is like possible, so how does a normal distribution work?
Okay.
I did it.
What that really means is deviation is normal.
Right on time, too.
Okay, so we're just assuming it is because it tells us?
Yeah.
Okay.
Also, a reminder with like percentiles, once you get towards the top, like 99 versus 99.99 versus 99.999, like we're talking about like
Yeah.
a semantics thing at that point.
Yeah.
Everybody good? How we feeling?
Not too bad.
Cool. So, you guys, we still have 45 minutes, 44 minutes. I'm assuming you guys want to take a break. That's fine. Okay, this was a lot of notes. Did everybody see how I updated?
Yeah, I love it.
All these due dates are all there for you to see. And should I take a picture for the notes?
Yeah.
For the
Just ironing the shorts.
we'll use that. Well, let's go ahead and crop that down and make it a little bit prettier. Oh no. All right, so we have more notes next week. I can't imagine they're gonna take super long. I don't know if we'll get through them no, we'll definitely get through them during the block period next week. And then you will have the rest of the week to work on any assignments / start reviewing for the test. I highly recommend you start reviewing for the test now. Particularly because the Unit 5 stuff can be tricky, especially after you learn the easiness of this. Like going back and revisiting that is a good idea, okay? You will have today and tomorrow to work on Lab 6, the rest of today and tomorrow to work on Lab 6A.
Is there a 6B?
Yes, 6B will be probably Tuesday, I think the way I have it set up is we'll finish the notes on Wednesday. Lab 6B will be Thursday. Review on Friday. Test Monday and Tuesday of the following week. You need the notes from Wednesday before you'll be able to do Lab 6B. Before you'd be able to do any of the analysis.